So with these few words, I'd like to hand over the baton to Professor Abhay Karandikar. I must mention, among many of the achievements that Professor Karandikar has had in terms of research, driving standard-driven research, he is one of the few researchers in telecom who has done this particular work when he was at IIT Bombay. Of course, IIT Kanpur, I can imagine it takes up a lot of time in various other issues that arise as a director. But he was the first chairperson of TSDSI. So in that sense, he set the tone and the direction that TSI, the leading chairperson, does make a big difference out here. Okay, and he has graduated many students with strong telecom background who are now faculty members at leading institutions, including IITs in the country. Okay, so his contribution will always be remembered in telecom. So with these few words, and I know he was a colleague of mine at IIT Bombay, so I know him quite well. So I'm not reading his formal introduction that would be there in a website or in a page out here, but I'm introducing more as a friend, okay, who was there at IIT Bombay. Okay, though I meet him much less now because as pandemic is one reason, and then of course he's very busy being a director out here. So Professor Karandikar, you are most welcome to give your address. Okay, and I'd like to thank once again NCC for this opportunity.
Thank you, Professor Desai, I think, for the very kind words. And I think, as Professor Desai rightly mentioned, that there is a need to now do a standards-driven research. And the focus of my talk today is to really motivate the audience to talk about the 5G journey, which has really made a significant impact on the global telecom standards. And let me just share my slides. Okay, so this is a brief agenda. I will just briefly talk about what is the characteristics of 5G and the standardization landscape which exists globally. And what are the requirements of rural India, especially, which actually led to the thinking amongst us that we need to do something different in terms of technology development and standards. Then I will talk about the low mobility large cell configuration, LMLC, which was first submitted as a part of the EMBB rural configuration in IMT 2020. Which was submitted as a part of the IMT 2020 family of standards in ITU, and we will see what impact it has made and is likely to make in the next few years. So first of all, I have to say here that most of the technical contents of this talk, I really owe it to the key contributions which have been made by researchers all across, IITs and leadership at various levels. So IIT Madras team, which is led by Professor Bhaskar Ramamurthy and Radhakrishna Ganti, he's very much here. Then IIT Hyderabad team, Professor UB Desai, Professor Kiran Kuchi, Dr. Said Hiraj and Aniruddha Venkatesh. CV team, which is Dr. Pluto and Priyanka Day. TSDSI leadership, Professor Bhaskar Ramamurthy, Dr. Kumar Shivarajan. So Professor Desai mentioned that I was the first chairperson. Actually, I was the first vice chairperson. Kumar was the chairperson, and together we really, formed the foundations of the organizations. Mr. Mittal and Pamela, who is really now driving and has really made significant efforts in making sure that these contributions, get heard and accepted in the various ITU and 3GPP meetings. And finally, of course, all these things would not have been possible if we did not get unflinching support from the Government of India, especially, the Ministry of Communications and Telecom Engineering Centers, their senior leadership right up to the secretary level, and secretaries at various times, additional secretaries at various times, and of course, Mr. R.K. Pathak, Mr. Kishore Babu, they have all been there all through this journey. As all of you know that 5G is going to be really different from the earlier generations of mobile communications, that is 3G, 4G or so, in the sense that it is going to be the technology which is going to be all pervasive and expected to touch almost all parts of human life. So whether it is a traditional high-speed broadband or the massive IoT, and which includes the areas such as smart homes, wearable, and even the diverse sectors like agriculture, industry, automotive, healthcare, manufacturing, public safety. It has a much bigger implications than maybe 3G or the 4G systems, and obviously therefore there is a much larger implications, not only in terms of strategic security, but also in terms of commerce and economics, because this is going to be the connectivity impacting each economic sectors. Now, if you look at the characteristics of the communications technology in the last few years, they have been always driven by continuous innovations. And more recently, we have seen the convergence of computing and communications leading to increased softwareizations, commoditization of networks, increased usage of cloud and fog edge computing. And this has really given us an opportunity to play a leadership role in the sense that except the RF front end and the antenna parts, most of the parts of a modern communication systems can be actually implemented in software on off-the-shelf hardware, and we can really leapfrog into innovating 5G or beyond 5G technology. However, what happens is that even though we can innovate the technology, because of the fact that these technologies needs to be interoperable, they are mostly driven by the global standards bodies, and they are like ITU. 3GPP is not really a standards body; it is a partnership project. But it is like it had become a de facto standards developing body, and then IEEE, IETF. And what happens is that the IPR which gets into the standards, which is called standards essential patents, they are owned by the individual member companies or individuals, like in the case of IEEE, and they really have an impact in terms of the evolution and deployment of the technology. There are a few other factors also, because communications technology are capital intensive, and both in terms of the equipment and also in terms of the cost of the spectrum, and also require the skilled manpower, both at the level of IPR generations and development, and also in terms of deployment and maintenance. So in this sense, the standardization and innovations really play a significant role. Now, if you look at how the world has moved in terms of IPR, it so turns out that the standards participations in 3GPP, which is the main partnership project where the standards contributions are made in the wireless communication systems, 3G, 4G, 5G, or beyond. India's participation continues to be low, and that is really the focus of this workshops. We would really like to see that this participations from both academia and industry is taken to the next level. While we can see here the China, US, and Europe participations are significant. And as you can see that in terms of approved contributions, it is being led by companies such as Huawei. In fact, my next slide will show that until 2G and 3G, a majority of the intellectual property rights were held by the Western world, that is the US and the Europe. In fact, this slide shows that 90% of the IPRs in the 2G, they were held by the US and Europe. And only 10% IPRs were held back then by Asia, that is China, Japan, Korea, and Taiwan. But as as we move from 2G to 5G, we can see that the balance of IPR is now slowly shifting to the Asia Pacific world. And in the 5G, you can see that almost 65% of the standards, essential patents or IPRs in other forms is being held, by the Asia Pacific countries. On the other hand, only 35% of the IPRs are now held by the US and Europe. And this is also among the Asian countries also, I would like to say that China owns a much larger percentage of the standards essential patents. And in China, Huawei is the biggest holder of these patents among various companies. So this is really a significant shift that has taken place. And since, as I mentioned, that 5G and beyond technologies are going to drive every sector of the economy, this has implications not only in terms of the strategic security, but also huge implications in terms of the economic growth, because these components are going to be form part of almost every part of our human life activity. And therefore, it is important that we seriously take the standards driven research and contribution to the standards as one of the important priority items. And as I mentioned here, that IPR ownership may actually dictate the economic and national sovereignty also, in the next decade. And not only the 5G wireless communication systems, but 5G and other cyber physical systems like AI and machine learnings, etc. All these put together, and cyber security, which is governing all these cyber physical systems, may actually control the world of tomorrow. And usually what happens that in the standards bodies, the technology is developed and standardized, they typically end up addressing the needs of the participants. And those participants or those stakeholders who do not make contribution to these standards bodies, they actually end up using either not so suitable technologies or suboptimal technologies. And of course, it has a far-reaching consequences in the sense that if you don't own the intellectual property rights, then actually it may even affect, in some sense, the economic sovereignty also. So I think these were the primary motivation that actually led to the formation of the TSDSI, and that were also the motivations which led us to make a lasting impact or contributions at the global standard scale. And that is really the 5GI journey. And I will take, next sort of 10 minutes or so to talk briefly about, this exciting journey. So, what is the motivation for, because one way is that, the standards activities are already going on in 3GPP. So one way is that, we can do our research and technology development and make those contributions into the 3GPP. But we really looked at, somewhat differently, that before we actually start working on the solutions, we also look at, what problems we want to address. Now, as you see that in the last 2-3 decades, India has seen a significant growth in the cellular mobile communications. In fact, the cell phones have become the primary phone for most of us. Now, we have almost forgotten using, the landline phones or making phone calls from the landlines. And while it became the primary telephone, when the shift happens towards the data usage and internet usage, it also becomes the primary access mechanism for the broadband access also. So that is how, the proliferation of 3G and 4G happened. Remember that unlike us, in the Western world, the broadband was always delivered to homes and offices through the ubiquitous fiber penetration or the cable penetrations. And of course, inside the houses or offices, you can have the Wi-Fi access. But in India, the cell phones became the primary access mechanism for broadband. Cell phones were used by in the Western world for broadband access mechanism primarily while they are on the move. So basically, the mobility was a major considerations. Now, despite this proliferation which has happened, a sizable population in rural India still does not have the broadband and internet access. As a matter of fact, even in our tier 2 and tier 3 cities, we don't get that kind of a mobile broadband experience as it is needed. So now the reasons for that is, of course, the technology, as I said, cellular mobile communications was primarily designed to keep different requirements and needs in view. And therefore, there was a need to rethink some of these 5G requirements, especially considering the rural areas. So first of all, in India, we have the administrative structure of a gram panchayat. There are about 250,000 gram panchayat and 600,000 or 6 lakhs villages. Typically, there are 1 to 3 villages in a gram panchayat. And these populations are relatively clustered in the different parts of the gram panchayat. So we can call that as village clusters, and therefore we will find a relatively sparse population. The other thing is almost all villages, you can see that they can lie within 10-kilometer radius of gram panchayat. In fact, 90% villages will fall within 6-kilometer radius. The second most important thing is that average revenue per user for cellular services in the country has been the lowest in the world. Almost, it is 100 rupees per month. And it is even lower in the rural India. So we really need an affordable technology. We need a technology which can give a large coverage area support to address our rural requirements. And finally, as I mentioned, we need mobility, of course, but we don't need very high speed mobility. First of all, we have a relatively small vehicular traffic in the rural areas. And secondly, even in the urban areas, we have a slow moving vehicles. So we are really not looking for, a very high speed mobility in the rural areas. And I think these aspects have been captured in a paper which was published in the Journal of Indian Institute of Science, ISC papers, which was authored by Radhakrishna Ganti. So you can look into this motivation in more details in this paper. But the fact remains that there was a need felt that we need to define the requirements in a different way than what have been considered and projected as the part of the user configurations requirements in IMT 2020. So what we thought is that the IMT 2020 requirement which were considered, they were not so suitable on rural India, primarily very high throughput like EMBB, IoT, URLCC, smaller cell size for high capacity. We don't need a high mobility support, which were the focus of the EMBB. And they were primarily driven by the needs of the major stakeholders, and which was actually the China, Europe, and the US. So we looked at the original rural EMBB configurations, and we found that Indian rural requirements were really not well supported. And finally, of course, as I said, it is not just a case of addressing the Indian requirements. It is also a case of contributing our IPR, which will address these requirements. So the motivation for 5GI was for twofold. One is that we want to have a technology which really addresses our requirement. And secondly, we of course want to increase our footprint in international standards. So just to recapitulate original rural EMBB requirement. So there on the rural EMBB requirement, the cell radius was considered 1 kilometer because you want to really address the small cell. Then the mobility KPI, for example, the configuration was 50% outdoor vehicles with a speed of 120 kilometers per hour, 50% indoor vehicles, which is like low mobility, 3 kilometers per hour, and 500 kilometers per hour is a very high speed mobility that was considered. Now, this kind of configuration is obviously not suitable for addressing the requirements of connecting the unconnected. And that is where we proposed a change to this rural EMBB configuration. And our idea was that, as you know, that the government of India has already launched an ambitious project of BharatNet deploying fiber in the rural India, where the fiber point of presence terminates at each Gram Panchayat location. And then the remaining 1 to 3 villages, as I mentioned, they get covered by using a cellular connectivity. So therefore, the idea was that in order to address these requirements, we need to focus on the large coverage area so that these areas can be covered from Gram Panchayat. So the cell radius cannot be just 1 kilometer. And secondly, we need to focus more on low mobility users. And of course, the Indian rural requirement may require a completely new channel model. So this was the configurations that was we proposed. Indoor users 3 kilometers per user, outdoor users pedestrian 3 kilometers per hour, and outdoor users in the car at best 30 kilometers per hour, and really not speeds of 120 kilometers or 500 kilometers per hour. So this was the LMLC requirements which we submitted, and finally they got accepted in WP 5D meeting in October 2017. And this is just a snapshot of IMT 2020 configurations. EMBB addresses enhanced mobile broadband. Under EMBB, there are these indoor hotspot EMBB, dense urban EMBB, and rural EMBB. As a part of the rural EMB, our Indian contribution has been LMLC for 700 megahertz, and basically, we are talking of sub 1 gigahertz a spectrum primarily to address the large coverage area, taking advantage of the good propagation characteristics of the lower frequency range. So this was got accepted as a mandatory requirement. So now once it gets accepted in ITU as a mandatory requirement, now the idea is to develop the radio interface technology which will address all these requirements. That is really the journey of the 5G-I then. So once you have the requirements get accepted in IMT 2020, then you have to develop the technology. And these are the 3 configurations that I mentioned. Configuration A for 700 megahertz, which is the existing rural models. Configuration B at 4 gigahertz, and configuration C of LMLC, which is what we had proposed as the mandatory requirement. Now, the obvious question was that we would like to propose changes in the 3GPP radio interface, which can actually take into account and address these requirements. So as a part of this, we found that some aspects of the 3GPP 5G specifications do not meet these requirements, and therefore it was considered necessary that we proposed add-ons to these 3GPP 5G specifications, which actually take care of our LMLC configurations. So 5G-I is basically a TSDSI radio interface technology, which is more or less based on the enhancements of our 3GPP release 15 in such a manner that even these LMLC configurations are also addressed. Primarily, basically, it provides large coverage area as compared to the 3GPP specifications. It supports LMLC, and it supports building penetrations for the NB-IoT. So very briefly, in 2 minutes, I'll just say that one of the important parts of the 5G-I is to propose a new modulation or air interface techniques, which is called pi/2 BPSK. It is basically a new waveform to increase the uplink coverage, which is valid for a cell radius of 6 kilometers. And I said this was needed primarily to increase the rural coverage area. This air interface is applicable for both uplink data as well as the control channel, and it ensures low peak to average power ratio. It is also resilient to non-linearities of power amplifiers, and therefore, even it can work at higher powers, and low order modulation schemes and tolerant to distortions. So these are some of the characteristics of the pi/2 BPSK waveform, which made us address the configurations which were defined in the LMLC. And with these modifications and the rest of the features which were already there in the release 15 of 3GPP, TSDSI had submitted a radio interface specifications to IMT 2020. Just for those of you who do not know the process, the way in which it works is that IMT 2020 defines the requirements, and then various standards bodies or projects submit specifications which meet those requirements. So while 3GPP submitted its own release 15 and later on release 16 and other releases as the specifications which will meet these requirements, TSDSI also independently submitted its radio interface specifications, which our claim was that 3GPP 5G specifications do not meet the LMLC configurations, while it is necessary to have these radio interface specifications which will meet the LMLC use case configuration, which is itself an accepted ITU standards. And I'm really happy to note that through a long and protracted efforts of several of us, which includes, as I mentioned, IIT Hyderabad, IIT Bombay, IIT Madras teams with the strong support from the DOT and TEC. Finally, I'm happy to report that in the November 2020 meeting, the TSDSI RIT finally got approved at the ITU as part of the IMT 2020 family of standards. And that is why, that specifications, we are calling it 5GI to differentiate it from the 3GPP 5G, which is also a part of the IMT 2020 family of standards. And now, of course, the government of India is looking forwards to make it as a national standards. So what is the benefits? Very quickly, it conforms to the our rural coverage requirements, and also incidentally the side benefit, it increased the number of supported users and spectral efficiency. And what is the ecosystem impact? The ecosystem impact is that in terms of device and infrastructures, fortunately it requires only minimal changes, only software based changes. And as I already mentioned, that most of the implementations of the 5G are going to be done in the softwares only. So this actually only needs some small changes, and as a result, it is possible for the global vendors also to incorporate these specifications. We believe that the long-term benefits far outweigh the small changes and some cost which the vendors will have to bear in implementations of these. So I think this is really the impact that which we are going to have. And as I mentioned, that this gives a small but a very impactful and a long protected journey where we have made a significant impact in terms of not only addressing the Indian requirements, but also making contributions at the global standards bodies. And these are some of the references, which actually describes the contributions which were made at various stages to 3GPP and also to ITU. So thank you very much, I think.
Thank you, Professor Abhay. I mean, for the motivation on why we require this kind of research-driven standards as well as the 5GI journey. So we have time for one quick question. We'll be happy to take one quick question.
Yes, yeah.
Radha, there's a question in the Q&A chat. You can just read out.
Actually, so question is that, pushing something into the standards require attending the standards body meeting. What steps are being taken? So yes, I think it is absolutely true that pushing something into the standards not only require attending these standards bodies, but also, liaising with other contributors and collaborators. So this is really a sustained effort. And that is what, earlier Professor Desai has mentioned, that we need to really do this in a concerted efforts. This definitely requires, now of course because of COVID, most of the meetings are happening virtually, but this definitely requires earlier, the travel, and therefore the travel support and the research funding. I'm really very happy that even the Ministry of Electronics and Information Technology had earlier set up the funds. And I'm sure that when more and more people start contributing and participating, both the DOT and MIT will be able to support such activities, because ultimately, it is in terms of how our country is making a dent into the ownership of the information and communications technology.
Thank you, Professor Abhay. Virtually thank you for the wonderful talk. It was really motivating and very nice to see the whole journey. Thank you for agreeing to be our keynote speaker.